All right, a little extra credit words for people who are already here and online. So the first word for attendance will be trash can. And again, if you're here in person or if you're currently streaming this live online right now, then that's an extra credit word. If you're watching the video at a later time, that's just your actual first word for it. Anyway, that being said, let me jump into this. Back at it. Morgan is online. Hannah is online. Fisher is online. Larissa is online. Galloway is online. Kincaid is online. Andrea is online. Lewis is online. Canterbury is online. Julia is online. Madison is online. Maddie. That's it. I think I've got everybody, at least online. So, in person, let's see. Abigail is not here. Mullins is not here. Cooper, not here. Hunter is in person with a WVSU shirt on. Neither of the Meltons are here yet. Crowder's not here. Reinhardt is here in person. Talbert's not here. Kennedy's not here. Madeline is here in person. Tate is not here. Well, he's online. Topanga is not here. Jones is not here. Hobson is here in person. Caleb is here. Crowder is online. Morning. Abigail is here in person. So is Kennedy here in person. 8 o'clock. Well, just quick reminders so we can jump right back into this last chapter. So again, the final exam is open all week next week. And it's online, so just take it whenever you want. You can still retake exam 3 until Friday. After that, then we can meet. So if anybody wants to meet with me to talk about exam 3, to get all the correct answers and to get the boost to your grade, then we can arrange that after Friday. Just let me know. And speaking of Friday, we will do the evaluations where you fill out the evaluations about me. So because of that, obviously I would need you to be in here physically. So Friday's attendance will count double. So meaning you'll get extra credit. So if you're here, instead of getting 2.4 points, you'll get 4.8 points. So it's like having a free day thrown into your numbers. And for some of you, you have over 100 points as it is, but then you'll just still even get more. So, you might think, oh, I don't need the extra points because I have perfect attendance. And you'd be correct. But, extra points, they never hurt, right? What else? I think that's it for announcements. I'm still playing catch up as predicted. A lot of people are turning things in and have, turned things in late. And as I've said before, I'm taking care of new material. And every time I'm caught up, I go back down to the bottom of my email list of all the things that have been turned in, and I start grading them in the order in which they were received. So, does anybody have any questions? All right. So, let's get started. Okay. There we go. Jumping back into this. Actually, let me back up 2 slides just so we can remember exactly where we were at. Get a little context. So that's where we actually left off, but let's back up, like I said, a couple steps and look at the big picture. So we're starting the beginning of this last of the major bullet points for the last chapter. So hopefully we can maybe finish this today, and then when we meet Friday, I can pull up exam 1, exam 2, exam 3, whatever it may be, and we could do, well, not exam 3, but anyway, we could do a review for the exam or some of the study guides. We'll see. We'll play it by ear. Anyway, so this is where we left off. Let's talk about conservation biology. That is a goal-oriented science seeking to understand and counter the loss of biodiversity. And that word I just said will be the first official word for attendance, counter. Like where you might chop up your food when you're cooking at the kitchen, counter. Anyway, that's conservation biology. Restoration ecology uses ecological principles to develop methods of returning degraded areas to the natural state. So this is a really long-winded way of saying, like, the top one is basically like how to do things and not cause harm, basically. And the second one is, all right, well, we've caused harm, so how do we fix it, right? So one of them's proactive, one of them's reactive. Generally speaking, that's not 100% accurate, but that's good enough for this level. Any questions about that slide? Okay. If you're watching the video, sorry, I can go back and, I just said the first official word for attendance. If you're watching the video, so not you guys in person and none of you who are streaming right now, but someone who watches this video later, don't just send the words, send a screenshot of when I said the words. Anyway, let's talk about biodiversity hotspots. This is the concept you should know for the exam. Hold on, let me think about this. Yeah, let's talk about it really quickly. Conservation biologists apply the understanding of population, community, and ecosystem dynamics in establishing parks, wilderness areas, and other legally protected nature reserves. The Cranberry Glades is a great example of that in West Virginia. You have to have a permit from the federal government to get onto the Cranberry Glades. I mean, you can go drive there and visit them, and they have walkways you can visit, but to actually get into the glades requires a permit. So that's a good example of something called a biodiversity hotspot. That is a relatively small area that has a large number of endangered/threatened species and a high concentration of endemic species as well. And you should know what an endemic species is. That is a species that is found nowhere else. And I would say that's a good independent work topic, but again, like I said, I'm already swamped with stuff that's been turned in late, so anything that's turned in after this, I really don't know if I'll have time to grade it. Wouldn't hurt to write it, but I can't guarantee you it'll get graded. But anyway, yeah, what I was getting at was endemic species, right? So what are some, not that you need to know this, but it would be an interesting topic for an independent work paper. What are some endemic species of West Virginia? Where can you find something here that you can't find anywhere else? Most likely, and I knew this once, I wouldn't say it's more of a West Virginia thing, it's a regional thing. So there's probably some species, for example, that you can find in the Appalachian Mountains that you wouldn't find anywhere else. But anyway, that's what a biodiversity hotspot, that's what an endemic species is. Here's a map showing you some of the big biodiversity hotspots. So any questions about those concepts? All right. Yeah, we will be able to finish this chapter probably today. We might even have an early day today. So conservation biology aims at sustaining biodiversity of communities, ecosystems, and here's a new thing for you. This is a step above, if you will, ecosystems. They're called landscapes. So again, to remind you, there's one that's not on the board, not the board, but on the screen. Remember when we talked about population, right? So a population is a group of the same species at the same place at the same time, interacting with each other. And then a step above that is communities, right? So then you're not just looking at one population in that area, you're looking at all the living things and how they interact. And then the step above that is ecosystems. So that is a community still, but now instead of just looking at all the living things and how they interact, we're also looking at how non-living things affect them, right? Like climate. How much daylight do you get per hour or per day, things like that. And then finally, this new one, a step up from ecosystems are landscapes. Landscapes are regional assemblages of interacting ecosystems, such as an area with forest, adjacent fields, wetlands, streams, and streamside habitats. So that was just an example. If you were to know the definition, I would say it's, regional assemblages of interacting ecosystems. That is the example, right? And then everything to the right is just an example. To the left, right there, that's the definition, and to the right, that's an example. So yeah, you should know what a landscape is. And around here, you can think of it, there's quite a few of them, right? So we are in a landscape. Across I-64 is like a forest ecosystem, right? We've got a river ecosystem on the other side of us. We have a field ecosystem in our quad. I mean, granted, it's a man-made ecosystem, but it's still there, right? So all these different ecosystems that are around us, and they're all interacting with each other. And that brings us to landscape ecology, which is the application of ecological principles to the study of land use patterns, right? So the goal of which is to make conservation a functional part of planning for land use. So again, it's saying basically, you're thinking about the environment when you build stuff. It's pretty much that simple. So any questions about this slide? All right. Your book also points out, if we're talking about landscapes, right? So again, a landscape would be a bunch of interacting ecosystems in the same area. So that would obviously bring us to this, which are the edges between ecosystems. So again, thinking about, the edge of the forest ecosystem to the edge of the river ecosystem that we have right next to us, right? There's an edge. And these are prominent features of landscapes, whether natural or altered by people. And they have their own physical conditions, such as soil type and surface features. And I'm sure you've seen this before. Like, how many of you have been to the beach? And on one side of the beach, it's sandy and there's ocean, right? And on the other side, it's still sandy, but there's different kinds of plants growing. But right there in between where the dunes are, right, that would be an edge in between an ecosystem. There's stuff that generally grows on those dunes that don't grow in other spots. And if they do, they don't grow quite the same way they do on those dunes, right? So that's a good example. Or I'm sure you guys have been hiking. Well, I'm not sure of that, but if you've been hiking, if you're in an open field, obviously that's one type of ecosystem. So you see a bunch of grass. And then as you approach maybe the wood line, right before you go into the forest, there's different types of trees growing right there at the edge of the forest than there are once you actually get into the forest, right? So again, these are the edges between ecosystems. They themselves they're almost like unique own little ecosystems. And there's some examples. You can see natural edges on the left, artificial edges on the right, but either way, like I'm saying, there's unique ecosystems. So again, imagine the plants that are growing right here where that red line is are obviously different than the plants that are growing right here where the grass is, right? But if you were to get there and zoom in, and if you could see, you would see that the trees that are growing, the plants that are growing right there at the edge are different than the ones that are growing kind of behind that, right? Kind of into the woods. Anyway, any questions about that? All right. So another important feature, if we're talking about all these landscapes, right, all these interacting ecosystems, is something called a movement corridor. I might ask you about a movement corridor too for the exam. You might need to know what this is. It's a narrow strip or series of small clumps of habitat that connect otherwise isolated patches. This will make a lot more sense on the next slide when I show you a picture. It's actually a pretty simple concept. It can promote dispersal, meaning it can help things get from one place to the other, usually animals, not always. It can help sustain populations, and it's important to species that migrate between different habitats. So that bullet point's kind of weird for us. It's, unless you're really studying it, you might not think about this, right? Because as a human, we can just easily go from one place to the next, right? And as a human looking at nature, we often see, especially animals, that do go from one place to the next, right? I constantly see birds flying, from one place to the next. But there are a bunch of species that cannot easily migrate between different habitats. You probably don't see them or notice them, but they're there and they're stuck in their little habitat because they can't get to the other one. All that being said, there are some downsides of movement corridors, and that's that last bullet point. They can spread disease, especially among small subpopulations and closely situated habitat patches. So small will be the next word for attendance. And if you're taking a screenshot, because you're watching the video at a later date, you take a screenshot that includes that arrow showing the word small, which is the next word for attendance. And again, if you're here now, you don't need to do screenshots. There's a picture of a movement corridor. I forget where this is, but yeah, that's a great example. And not all movement corridors are like this. So I remember when I first learned about movement corridors, this was also the example I was given. I mean, it may have been a different picture, but it was an artificial bridge so animals could cross the road. So for years after learning this, in my brain, that's what a movement corridor was. But there's other movement corridors. It's not just a bridge. So here's another good example. What you can't see in this picture, imagine on this side of the picture, like where we can't see, you know, maybe behind the lens, imagine there's a big forested area like there is right here, right? So now imagine there's some species that like to live in the forested area, but they're stuck where we are behind the camera. And they normally couldn't get to that other wooded area through that big field because, again, not all animals can just make it, right? Again, we think, you know, picture a bird, sure, most birds probably would have no problems getting there. But some species do need that help, and that's what we need these movement corridors for. And you can see one of them here, right? So this little thin area is connecting otherwise isolated habitats. There's one over here too, right? This one, it's like a little green river almost, or a river made of trees instead of water. See, you can see how they're all connected. Anyway, it's just an example of a movement corridor. Are there any questions about that? All right, we are really almost done with the entire semester here. Let's talk about restoring ecosystems. And that brings us to a word that you might need to know, bioremediation. It's kind of in the name, so it should be an easy one for you. Bioremediation. That is when we use living organisms to detoxify polluted ecosystems. We've got some people in this building, some scientists / faculty who are working on bioremediation. They're looking at different plants and also genetically modified plants that we can plant near old coal mines, because coal mines have a lot of heavy metals in the soil, right? It's not a good area. Even when we're done coal mining and then we leave, that area is still bad for the environment. So, and again, I'm just giving one example, but so we're looking at these plants that we can plant to help get those heavy metals out of the soil and help restore it to what it used to be. But anyway, the book examples are bacteria that are used to clean up old mining sites and oil spills, and also plants to remove toxic substances such as heavy metals, right? So this bottom bullet point from your textbook is also basically the example I gave as well. But those are just examples. As always, I'm not going to ask you for those. I've also read recently, like the headlines, I haven't read into it. I've heard something about I think it's a bacteria. Anyway, there's some sort of microorganism that is now they found that could eat plastic, if I'm remembering this correctly, which would be amazing, right? To be able to clean up all the plastic in the ocean. But anyway, any questions about bioremediation? All right, here's a picture from the old textbook. This guy's planted, again, these plants to help take out heavy metals out of the soil. Some projects have a broader goal, right? They want to return ecosystems back to their natural state. So not just cleaning up a mess, but in this case, just undoing everything that humans have done to make something artificial, right? Try to make it more natural. So again, I'm going to put it next to this. This is just an example. So I'm going to go through it, and I'm not going to test you on it. And if I remember correctly, too, this is also from the old textbook, but I kept it anyway because it is a great example. There's a river called the Kissimmee River in Florida. It used to be shallow and meandering, and it would connect two lakes. It still does connect two lakes, but back in the day, they straightened it into a canal, right? Because they're just trying to figure out how to get things moved back and forth in Florida. So for humans, it made sense to straighten it into a canal. It was very useful. That was about 60, maybe even 70 years ago now. To do that, they had to drain 31,000 acres of wetland, which is a pretty big deal. And as you might imagine, that had a significant negative impact on the fish and all the other things that live in that area. So this is just part of it. I'm not taking questions yet. Let's just keep talking about it. So the restoration project involves removing water-controlled surfaces such as dams and reservoirs, also some channel modifications, right? So they're trying to get it back to its meandering ways like it used to be. They also filled in about 35 kilometers of the canal. And the first phase was completed in 2004. And again, this is a pretty old example. I need to check up on it. I'm not sure if the whole thing's completed or not yet, but I think if it's not complete, it must be close. Here's what it looks like. All right, so here's the river we're talking about. It's between Lake Kissimmee and Lake Okeechobee. You can see on the left what it looks like now because of the restoration, right? Because right here on the right is what used to be a canal. So it used to just be a straight, relatively deep, I don't know, artificial river, right? That's what a canal is. But now they've filled it in and things are back to the way they used to be. And unless you're really familiar with aquatic ecosystems, that probably doesn't mean much to you because you're like, okay, big deal, you just changed the shape. Well, it wasn't just the shape that changed. It's the speed of the water, probably the how clear the water is, what nutrients are in the water. So yeah, these are completely different ecosystems. So the things that were living in the canal, I bet most of the things that lived in the canal probably couldn't live in the river, and vice versa, right? So we're trying to make things back the way they used to be. Anyway, it's just an example. Are there any questions about that? All right, the last bullet point of the semester. Then we'll be done early for the day, which is good, because that'll give me time to go back and grade some old stuff that has been turned in. What time is it? Uh-oh. Can someone online confirm you can still hear me? Sorry. I hit a button.
Yes, we can
hear you.
hear you.
Okay, thank you. All right, so here we go. The goal of sustainable development. As the world population grows and becomes more affluent, meaning, more money, demands will increase for ecosystem services, including, but not limited to, food, wood, water, a bunch of other stuff. So the goal of sustainable development is to meet the needs of today without limiting the ability of future generations to meet their needs. That's basically, that bullet point right there is basically like the purpose of the whole next class. So if you were to take Bio 108, that's it wrapped up in one bullet point. The goal of sustainable development is to meet the needs today without limiting the ability of future generations to meet their needs. And just going back to an example we used before, when we were talking about the fisheries, the North Atlantic cod fisheries, of course, the purpose of that example is an example of how they mishandled the situation. But anyway, we could also look at it as a good example of if you catch more fish, just as one example, than are being born every generation, then eventually you're going to run out of fish, right? That is not sustainable. But anyway, any questions about this slide? All right, the next word for attendance is the one right next to that blue, the red circle. It's goal. So again, if you're watching this video at a later time, get a screenshot where it says goal. So sustainable development depends on a few things. It depends on continued research. Hopefully through all these conversations we've had since we started talking about ecosystems and populations, hope you can see research is important, right? Because of a lot of stuff I've been teaching you from this portion of the textbook is not necessarily common sense, right? Remember that the woodpecker situation where what was killing it was that we were not letting the forest catch on fire, right? So that was kind of, in my opinion, that was kind of anti-intuitive, right? Counterintuitive, right? So that to fix that problem, we had to let the thing burn down. Which again, that's not in my brain, wouldn't be something you would think of. Or all those examples of the invasive grasses, right? I said, imagine looking out and just seeing this beautiful field of grass. You would probably think, oh, this looks good. This must be good for the environment, right? It looks very green. Green is good. But in that case, that grass was invasive, right? So it wasn't good. So again, my point being, one of the many reasons we need continued research is because a lot of this stuff is not common sense. Now, that bullet point is almost not very important for you guys because for the most part, none of you are biologists and probably won't be doing any continued research. But this is important when you think about, when you get older, or maybe even now, once you start working for certain companies, once you start buying things from certain companies, once you start voting for certain policies and certain candidates, that's something to keep in mind. Anyway, sustainable development depends also on the application of ecological knowledge. Of course, that bullet point is really just a follow-up of the first one, right? We want to do this continued research, and then we want to apply the things that we figure out. And here's what I like. This is a good one, a really good one. And I think this is only from the old textbook, but I kept it in because this is a really good one for non-biology majors. Sustainable development depends on the connections of life sciences, like biology, with social sciences, economics, humanities, right? So all these other things that you learn in your undergraduate degree that have nothing on the surface to do with biology, they are still important. And this is kind of what I got at, was getting at it the first time we met, talked about the syllabus. I was saying, you know, the purpose of an undergraduate degree isn't just to learn your one specialty, right? So to get a broad education so you can be a critical thinker and make smart decisions, smart, educated decisions. And that's why, again, biology is just a big part of your entire degree. And they all are interconnected, especially if you've had my Bio 108 class, or if you will have it. You see there's a lot of this. Life sciences with social sciences, economics, humanities, right? And in that class, we talk about religion, we talk about philosophy, obviously government, federal, state, local government. Yeah, talk about, you know, all those things, economics. Anyway, any questions about that side? All right. Sustainable development aims to conserve biodiversity, but also improve the human condition. And I like this. This is also an important fact, right? Because a lot of times some people get so stuck on one or the other that they fight with each other, right? So we need to help the environment, but also we need to take care of humans, right? So it's a delicate balance, and I think that's where a lot of debates come in for the environment. Like coal is a great example of that, right? Coal is obviously really bad for the environment. There's no denying that. You can lie to yourself about it if you want, but at the same time, especially in West Virginia, we need it to improve the human condition, right? That employs a lot of people. It's also a very cheap source of energy, right? So again, we have to balance these things. So do we take care of the environment or humans? We have to do both. Anyway, public education, political commitment, and cooperation of nations are essential to this success, and the awareness of our ability to alter the biosphere and jeopardize our own existence as well as the existence of other species may help us choose a path towards a sustainable future. And like I said last week, I think it was, you know, I'm not one of those people who likes to say, oh, if we don't fix this by this date, then by this date, the world's going to end, right? I'm not saying any of that. I like to be very broad and just say, look, this is a life or death situation in general when we're talking about the environment. Sometimes it could be immediate. Maybe it's hundreds of years away. I don't know. Either way, we need to be sustainable, right? To avoid our own death, whether it be next year or next millennium. Anyway, here's some pictures. You see some people promoting aluminum recycling. Oh yeah, that reminds me. No, I think this is one of the only semesters people didn't do this. But to remind you, you could have brought in one bag of cans per week for 5 points of extra credit. So we're meeting one more time. If you want to bring in one bag of crushed cans for extra credit, then I'll see you on Friday with that. And that's it. So the last word for attendance is going to be discard. So again, if you're watching this video at a later time, take a screenshot right there where it says discard. And the rest of you, use this extra time to get caught up on some work. I'm going to use this extra time to get caught up on some grading. And I will be online for office hours if you need me. Can you send it in an email just in case? Thanks, you too.
I think that's what I did wrong. I didn't originally, because I had never looked forward. I never saw that this assignment was here. I shared it like I did every other.
No, that should be fine.
It was March 20th.